Well, really what I want to talk to you about today is some of the importance of identifying age of first puberty and what are some predictive factors. Are we capable of identifying predictive factors that are going to help us identify those gilts that may come into estrus earlier in life, or if also possible to exclude those gilts that may not, because that's just about as important after what Dr. Pullman presented and the number of those P0 pigs that are incapable of demonstrating a heat and don't get bred, and you go send them back out the door after you've got $350, $400 wrapped up in them. So the importance of age of first puberty is it has a tremendous impact on the profitability of any swine enterprise because the investment, the upfront investment in a gilt and a replacement gilt, and the labor that's associated with replacement gilt development. Gilts that demonstrate puberty earlier have less non-productive days than those that don't. This is particularly reinforced if you're breeding based on their third cycle and not on a specific time. So the earlier they come into heat, the earlier they're going to get bred, the fewer non-productive days they're going to have. Even from a standpoint, if you're breeding after day 200, bringing them in from a gilt development barn, if they're already cycling, they're likely to have fewer days to first service than their cohorts that aren't cycling. So the other thing too would be if you're breeding at a younger age or a younger age for those gilts that have came into puberty sooner, they're going to have those that are heavier at first breeding tend to be heavier than their lighter counterparts at first breeding for the rest of their lifetime. So those pigs are going to eat more the rest of their lifetime. You may see some differences in the size of those pigs, the size of the pigs that they wean. They might be slightly larger from heavier sows. But they're going to remain heavier for their lifetime production. So age of first puberty is an indicator of lifetime productivity. So those gilts that are having the follicular dynamics, the follicular growth earlier in life, and demonstrate that first behavioral estrus sooner, typically have a longer lifetime productivity. And as we also have heard today, that there's multiple ways to define lifetime productivity, and so some of this may be in how you define lifetime productivity. So another thing with lifetime productivity is it lacks significant heritability, and it's, as Dr. Flowers has demonstrated quite nicely in the last presentation, the last session, is that environmental factors such as in utero environment, pre-weaning environment, and post-weaning environment all can have a pretty influential outcome or impact on a gilt's ability to respond to the gonadotropins from the hypothalamus. So if you look at the age of puberty and its impact on fallout in a herd, this is a paper published a couple years ago by George Foxcroft's group. And really what they did in this work here, they identified gilts. They started heat checking, I think, around 140 days of age. Identified those gilts that came in that first third, 140 to 160 days, something like that. Late and intermittent puberty, and looked at these gilts and their stayability through 3 farrowings. And those gilts that didn't demonstrate estrus by 180 days of age, yet were retained in that gilt replacement pool, had a higher fallout after they were all bred. So meaning that if they didn't cycle before 180 days, but were maintained in the gilt replacement pool and eventually cycled and were bred, they still had a higher fallout rate than their cohorts that cycled earlier in their life. So we've talked a little bit about the hypothalamic pituitary gonadal axis. I just wanted to put this up there. I show this to sophomores at Iowa State. I show it to juniors, and I also show it to graduate students, and just beat them over the head with understanding the hypothalamic pituitary gonadal axis, because that's really the driving force that enables these pigs to demonstrate and respond to the environmental cues that enable them to undergo puberty. And really what we're looking at the beginning is the hypothalamus has GnRH secreting neurons that are capable of releasing pulsatile secretions of GnRH. And that GnRH binds to receptors in the gonadotrophs of the anterior pituitary and causes them to release these gonadotropins, FSH and LH, the same components that are in PG600. FSH and LH, they bind to their receptors on the granulosa and theca cells. And really the outcome of that is the production of androgens in the theca cells and those granulosa cells converting those androgens into estrogen. Well, early and tertiary follicle development, that estrogen serves as kind of a negative feedback mechanism and contributes to blocking GnRH and FSH production from the hypothalamus and the pituitary. But as that follicle continues to grow, that estrogen will eventually become a positive feedback mechanism at the level of the hypothalamus and cause that surge release of luteinizing hormone that will initiate that first ovulation. Okay, and that first ovulation is going to result in the luteinization of those theca cells and granulosa cells. You're going to have the production of a corpus luteum. And this progesterone from that first ovulation is critical for the central nervous system priming to enable that gilt to demonstrate the behavioral estrus when she comes into contact with the boar. So having that progesterone upregulation or priming of the brain, enabling it to respond to estrogen of the subsequent cycle is critical. So that's on a cycling animal, but what happens, how does this get started in a gilt that's prepubertal? And one of the big things that are the newer mechanisms in the last decade that's really been proposed is this GPR54, which is a receptor, and the ligand for that receptor, which is kisspeptin. And GPR54 was kind of identified as the puberty gene, thanks to it, a first cousin marriage that produced kids that were not capable of achieving puberty. And then they identified mutations in the GPR54 receptor, which is in the hypothalamus. And essentially what kisspeptin does is it's regulated by leptin, or proposed to be regulated by leptin, and its secretion binds to receptors in the hypothalamus and initiates those first pulsatile GnRH secretions that enable that first bolus of FSH and LH to stimulate those gonads. Okay, so this is some work done by Clay Lentz when he was down at Georgia. He's now at the USDA and Clay Center. And they utilized kisspeptin and injected that into prepubertal gilts. I think these were 130 or 140 days of age. And we're basically able to demonstrate that injecting of kisspeptin into these gilts at that age was capable of eliciting a luteinizing hormone and a FSH response. So essentially that kisspeptin coming from the peripheral of the body stimulates the hypothalamus, those GnRH secreting neurons, to release FSH and LH, and that kind of initiates that wave of follicular growth. So what's that look like? Okay, so this kind of goes back to a couple years ago. Myself, Aileen Keating, and Lance Baumgard were collecting some ovarian tissues from, actually we were doing a heat stress project, and we were heat stressing some gilts that were all about 98 days plus or minus 4 days of age. And we were just struck by the fact that out of those 48 pigs that we sacrificed, 27 of them had ovaries that looked just like this, just robust tertiary follicle development. Okay, and the other 21 looked just like this, and if they didn't look just like this, they had 1 to 2 millimeter follicle coming off of it. So there was a huge variation that we were seeing at days 95 to 98, where some of these animals were demonstrating follicular growth and development, and other ones were really not putting anything together by the way of a hypothalamic pituitary gonadal axis. And so that's kind of what's driving our hypothesis, is that variation, gilts that demonstrate follicular activity earlier are going to achieve puberty earlier, and then we can capitalize on some of that variation that's occurring prepubertal around the 95 days of age to identify and predict those gilts that are most likely to come into heat. So that's what we wanted to test. And additionally, we thought that these gilts would be phenotypically distinct at a specific time frame. So the objective really was to identify specific times. So we looked at day 75 through 115, and I'll get into that we could demonstrate variability within a specific phenotype with regard to follicular development to kind of look at which of these gilts are demonstrating tertiary follicle development on their ovaries. So the other objective was to determine the feasibility of measuring some of these parameters. We looked at using transabdominal ultrasound. That didn't work well when you're trying to look for 1 to 2 millimeter follicles on an ovary. We looked at vulva development. Dr. Flowers mentioned the utility of the vulva as an estradiol bioassay. We've also pulled blood and are looking to measure serum estradiol levels. And we've also looked at body weight, or looking at body weight at these different time points to see if there's a relationship between these factors and their age at first puberty. So we began with 155 gilts that were plus or minus 2 days of age. So they all came into the barn, weaned pigs, 21 days, plus or minus 2 days. And on days 75, 85, 95, 105, and 115 days of age, we collected body weight. We did an ultrasound, a transabdominal ultrasound, and tried to score on a scale of 1 to 4 the level of follicular activity that we could identify in their ovaries. We measured the vulva width and the vulva length using digital calipers, and then we also used those values to calculate the vulva area. We drew blood on 155 pigs every 10 days, stored that, and we're planning on using that for serum estradiol assays. And then also at 10 days, we sacrificed 10 of the gilts, randomly selected 10 gilts, to look at the variation in follicular development and kind of validate what we had already seen at day 98, but to see how early that's starting and how late it's going. And we also then looked at the uterine weight. Dr. Flowers also mentioned if you compare the external genitalia, the vulva, it's generally a pretty good predictor of the rest of the uterine wet weight. So from those, after we sacrificed 50 gilts, so 10 gilts at each time point, the remaining 105 gilts we started heat checking daily at 129 days of age, and we did that until 200 days of age. So every single day heat checking, plenty of bore exposure starting at 129 days. We didn't have the first gilt came into heat at 140 days of age. So and then we worked towards determining the association between these phenotypes that we collected on 75 to 115 and the age of first estrus. So if you look at the body weight gain of these gilts over time, at day 75 they were right around 38 kilos, and they put it on pretty good. At 115, basically put on about 40 kilos. So they're about a kilo a day, which wasn't too bad. We looked at the vulva length during the same time period, and you could see a significant, I don't have the p-values on here, but there's a definitely day effect looking at the length of the vulva as those gilts continue to grow and develop. And then the same thing with the vulva width. And if you multiply the vulva width and the vulva area, or the vulva length, you're going to see the same sort of pattern in the vulva area. So I'll just remind you that kind of what elicited this project was all the disparity or the variation that we were seeing in the follicular dynamics at day 95. So the reason we went 20 days before was hopefully to start collecting data before we started seeing variation in follicular phenotypes, and then also out to 115 where we expected all of these gilts should have some level of tertiary follicle development at that time. And that's really what we saw too. And so if we look at the 10 gilts, this is just the frequency over here on the left. And if we look at the 10 gilts that we sacrificed on day 75, for all 10 of them, none of them had follicular development. If you look at day 85 and 95, these red bars kind of indicates they had between 1 and 10 small follicles that were at least 2 millimeters in diameter. And then these green bars kind of represent anywhere from 10 to 100 tertiary follicles on those ovaries, so similar to this. This is kind of the blue bars would be represented by these types of ovaries. The green bars are what you'd see here. And so that's really what we saw too. We wanted to see what's the time point. We wanted to pinpoint the timing and age and development where we're going to see the most variation in a cohort of groups that are the same age. And really what you can see is around 85 to 105 days is where we're seeing that difference. So these would be the ovaries that I would expect that when Dr. Flowers gives an injection of PG600, these are the ones that are going to have that vulva swelling and redness in response to that PG600. And the reason being is that every one of these follicles has a lining of granulosa cells, and it's those granulosa cells, if you think back to that cartoon image I showed you before, it's those granulosa cells that have the FSH receptors that are capable of synthesizing estradiol in response to that PG600 shot. And that's why you'd see the vulva swelling and enlargement in gilts that have this follicular growth or follicular activity. So if you kind of picture this variation from no follicular activity up to almost all the gilts, 9 out of 10 of them having ovaries like this, and then kind of looking at the uterine wet weight, and we can really see that that as a whole, if you just look at day by day, there's an increase in the uterine wet weight from day 75 up to 105. And then once all those gilts have a similar level of estradiol production or tertiary follicle development, we don't really see much of an increase from 105 to 115 days. So what that's kind of indicating to us is that the big difference, the big variation that we're seeing, the timing is going to be somewhere between this 85 and 105 days with regard to taking a phenotypic measurement on these gilts and being able to predict those that are having that initial follicular activity prior to their cohorts. So then we'd kind of gone through and started heat checking at 129 days. The first few gilts, we had 4 come in the first between 140 and 145 days. And what you can see here is kind of just a distribution, about as good, pretty as a distribution, I guess, as you can get with only 105 gilts. What I would point out, too, is that we had 26 that by 200 days, after 60 or 71 days of bore exposure, still did not demonstrate a behavioral estrus. So we wanted to back up and say, okay, so one of the things that's a little bit difficult is making these associations. So we wanted to associate the vulva width and the vulva area to their age of first puberty. Well, the problem is when you have 26 out of 105 that don't come into heat, that means you don't have a date. So it's hard to do a correlation when you don't have a value. You could make up a value and take a stab at it, and your correlations would be pretty good. But what we decided to do is really just group them into either estrus or no estrus, and then go back and look, okay, what's the association? Is there a relationship between their body weight at day 75, 85, 95, 105, or 115 on whether or not they're even going to come into estrus by 200 days or not into estrus, or not demonstrate any estrus? And what we saw is that really there was no relationship there. And I'll come back to this because the day 75 body weight actually has some interesting merit to it. But when we start looking at, or I'll come back to it right now. So the day 75 body weight, one of the things that was interesting, if we did a Pearson coefficient correlation, is that there was a significant relationship between the weight at day 75 and the age of first estrus. Okay, so this changes. So instead of 105 gilts that we're looking at, this was a 79 gilts that actually had a behavioral estrus that we were able to do this correlation. And those gilts that were heaviest at day 95, or day 75, sorry, actually had a better chance of coming into estrus earlier than their cohorts. And what you can see is I'll just kind of click through at the different days. You look at day 85, that there's no significant relationship. Say the R value is in the same direction, but there's still no relationship statistically. Day 95, again, still no relationship. Day 105, no relationship. And day 115, it's even further away. And I think what I was listening to Dr. Flower's presentation, one of the things that I got to thinking about here is that these pigs at day 75, we might still be seeing some of their positive effects of being weaned in a litter, or having an advantage coming out of the weaning phase. They're growing better, and some of that gets carried on for several weeks into through the nursery phase. So these 75-day-old pigs are probably looking at about 10 days outside of the nursery. So I just thought that was kind of interesting that while body weight at day 75 was not predictive of whether or not they were cycled by 200 days, it was predictive on how soon they would cycle if they do. So if you look at that, and another way of breaking that down is if over here on the left-hand side, these are those gilts, the body weights on day 75. Over here on the right are the body weights at 115 days. And if you just break them into those 105 gilts and break them into the top quartile, the bottom, and the middle 2 quartiles, and if you look at in the blue bars are those gilts that came in by 180 days, and the red bars are those gilts that came in by 200 days. And if you just compare those top 26 gilts, the 26 heaviest gilts, to their bottom 26 gilts at day 75, 77% of those cycled within 180 days, compared to the bottom 25%, only 46 of those, 46%, cycled within 180 days. And then you can kind of see it by 200 days, that the disparity is not quite as significant. So I think this just kind of lends to the fact that that day 75 body weight is a little bit more valuable than, say, 115-day body weight, where you don't see the disparity. Here you got 69% compared to 54%. There's a 15% difference in those gilts, whether they'll cycle or not by 180 days, compared to a 31% difference by segregating those based off their body weight at day 75 compared to 115. So we also looked at the association with vulva length compared in their association with puberty by 200 days. And really, this is the chi-square values for each of these days. And what you see is there's really no relationship, except you start getting closer to a relationship by day 95 of age, even though it's not as strong a p-value as we'd like to see. And I think that's probably one of the downfalls of the project, is that we only had 105 gilts that we were getting the data on. But we started to see those trends. If you look at vulva width, it's the exact same pattern. And what that comes back to, I'll remind you, is day 95. This is where we're seeing that variation in the follicular activity. This is when the tertiary follicle development is happening in about half of the gilts, and in the other half, they're still really not responding yet to those initial pulsatile secretions of GnRH from that hypothalamus. So if we look at the correlation between vulva width on day 75 to the age of first estrus, again, we don't really see anything there, but as we go through and start looking at day 85, is there a better relationship? Still nothing there. Looking at 95, nothing there. But when you look at the vulva width at day 105, you start to see a relationship between the width of the animal's vulva and the age of first puberty. So this is, again, based on those 79 gilts that came into estrus. And if you look at 115 days, you start to see even a stronger correlation between those gilts, between the vulva width on day 115 of age compared to the age at first estrus. And I think what we're seeing there is the timing effects of, these are probably the gilts that came into, or that began the tertiary follicle activity around day 95 earlier. So they've had several days, 10, 20 days of estrogen acting as a potent mitogenic factor, stimulating the growth of that reproductive tract, and you're seeing that externally by the width of the vulva. So again, this is kind of some of the same associations that we saw. Again, the vulva area association with whether or not they cycle. So do they come into heat or not? Again, the best timing for that is around day 95 of age. Okay, and then these are the kind of the correlations. The last correlation I showed you on the different days was the vulva width. This is the vulva area, and really what you see is a lack of correlation. So it's really, what I thought was interesting as well is that the vulva area is not as predictive as the vulva width itself. And I think if you're measuring the width of the vulva, that's a better indicator of follicular activity and estradiol production from those tertiary follicles on day 95 to 115 of age. So last couple things I wanted to go over and look at was, if we looked at the vulva area, how can you use this in an applicable way? And one of the ways is sorting out those small ones, those gilts with the small vulva area. And it kind of gets back to this timing on day 95 to 115. If we were to just take a normal distribution of those vulva areas on the 105 gilts that we looked at and break those into all those gilts that were within this one standard deviation or greater than one standard deviation from the mean, as opposed to those gilts that were less than one standard deviation from the mean. And what you see on day 95 and on day 85 is that there's really no predictive capacity in the vulva area. But when you start looking at day 95, 105, and 115, when you look at those gilts that had a vulva area that was lower than one standard deviation from the mean, had dramatically lower ability to cycle by 180 days of age. So on the case of the vulva area on day 95, those gilts that were less than one standard deviation from the mean, 30% of those cycled by 180 days of age, whereas the ones that were within or greater than one standard deviation from the mean was about 64%. So again, looking at this again from the vulva area association with puberty by 200 days of age, similar pattern, what we saw with 180 days of age, in that Those gilts that had the smallest 17, 18%, the smallest 17 to 18% of those gilts were less likely or demonstrated a lower percentage of their ability to demonstrate a behavioral estrus within 200 days of age, based on their size at 95 to 115. I think what this is really telling us here is that at 75 to 85 days, you're really not seeing that tertiary follicle activity that's necessary to demonstrate a external phenotypic measure that can be utilized for these predictive purposes. So I think what we're starting to see here on this kind of what I would say is a pilot study where we used 150 pigs to really identify and pinpoint the appropriate times to take these kind of measurements is that there's an association between vulva development on day 95 and the ability to achieve puberty by 200 days of age. And of those animals that do achieve puberty by 200 days of age, the two best correlations with age at first estrus were their body weight at day 75 and the vulva width at days 105 and 115. And so these developmental time points represent specific days and age that we could make many observations to distinguish gilts with a high and low probability of achieving puberty by 200 days of age, and also distinguishing which ones of those are more likely to come in sooner. And I think Dr. Flowers did a good job in his presentation earlier stacking up some of these correlations between different phenotypic factors and how together they represent more of the variation that occurs in regard to a phenotype. And I think when you start looking at body weight at day 75, looking at vulva width at days 105 and 115, those are going to be some of the indicators. And I think when we get the estradiol measurements done on day 95 and 105, that's going to even strengthen that and tighten that up a little bit more to be able to make some predictive measures. Some of the other things, I was going to mention one of the other things that we'd like to do too is going back and looking at some of the blood biomarkers and identifying novel proteins that are in the blood from those gilts that we heat checked for 70-some days and didn't have a single behavioral estrus. Those 26 gilts compared to the 20 gilts that came in between 140 and 160 days. So what's in their blood that's different, not just estradiol, not just FSH and LH. There's other biomarkers that are circulating in that blood, and I think those are the ones that we need to really focus in and hone in on if we can find something that's a little more predictive and quantifiable that can be measured on farm at a young age to be able to make these types of predictions.